Welcome to this explainer. We're diving straight into something that is quite literally changing the game for modern education. If you've spent any time in a physical lab, you already know the massive difference between reading a textbook and actually getting your hands dirty. But what happens when the physical limits, like crazy high costs and safety hazards, start holding back what we can learn? Well, today we are unpacking the virtual science revolution.
Because think about it, what is the core challenge of a physical lab? It's the danger. If you're studying volatile chemical reactions, the risk factor is huge. You need expensive gear, constant supervision, and honestly, accidents still happen. Because of that, students are often held back from doing the really fascinating, complex experiments. So today, we're exploring the ultimate workaround, how to practice dangerous science without, accidentally blowing up the classroom.
Here is our agenda for today. 1. What are simulation labs? 2. Why virtual labs work. 3. Bridging theory to reality. 4. The future of science. And 5. The PraxiLabs experience.
Let's jump into section 1. What are simulation labs? Redefining the laboratory experience.
So what exactly is a scientific method simulation? Basically, it's an interactive, fully immersive 3D virtual lab. And interactive is the absolute key word here. We aren't talking about passive video learning where you just watch someone else do the cool stuff. You are actively running the entire cycle. You form the questions, you tweak the digital variables, and you analyze the data yourself.
Instead of just following a rigid set of instructions because you're short on time or restricted by safety rules, you're the one in the driver's seat. You get to truly explore and test hypotheses in a dynamic space. And the best part? You can make mistakes, which, let's be honest, is a fantastic and totally necessary part of real science. Only now, you do it without wasting thousands of dollars in consumable materials.
Moving right along to section 2, why virtual labs work, the data behind the digital shift. There are really 4 main pillars that perfectly contrast the limits of the physical world with the endless possibilities of the virtual one. First up, safety. You get completely risk-free experimentation. Second is the sheer cost efficiency. No more buying million-dollar microscopes for every single student. Third, unrestricted accessibility. Want to run a complex assay at 2 a.m. in your pajamas? Go for it. And fourth, visualization. You can finally see abstract, microscopic processes, like molecular fields, that are pretty much invisible to the naked eye. And the data backing this up is seriously cool. Check out this recent physics study, comparing 2 classrooms, one using virtual labs, the other traditional. Look at the motivation metrics. The virtual class scored in the high category, while the traditional class was stuck down in low. Same thing for concrete problem-solving skills. High for virtual versus medium for traditional. And yes, an independent samples test confirmed this is a statistically significant difference. When you remove the friction of the physical world, student motivation and skills absolutely skyrocket.
Which brings us to section 3, bridging theory to reality, contextual learning in action.
So how exactly do we bridge that gap from academic theory to reality? It happens in 4 steps. Step 1, you contextualize the problem. The simulation drops you into a real-life scenario, like testing local water quality or analyzing drug reactions so you know exactly why the science matters. Step 2, you safely manipulate the variables. Step 3, you observe the direct cause and effect outcomes. And finally, step 4, you transfer those skills. The hypotheses and testing you do digitally mirrors exactly what's required in massive industries right now, like healthcare and engineering.
All right, section 4, the future of science. What's next for EdTech?
Looking ahead, the future here isn't just about turning old, existing experiments into digital copies. We are rapidly moving toward intelligent, AI-powered scientific environments. Soon, artificial intelligence won't just grade your work. It'll act as an active research partner. It'll suggest hypotheses you might have missed, help you design the experiment, and crunch massive datasets in real time while offering adaptive guidance.
And then there's the immersion factor. We're talking fully interactive 3D labs with virtual and augmented reality. But the real game changer is haptic feedback. This tech will actually simulate touch and physical resistance. You won't just see the science, you'll physically feel the procedures. You'll literally be able to interact with invisible chemical reactions right in front of your eyes. It's wild.
Plus, the whole thing will offer completely personalized learning paths. The simulation adapts directly to you. Crushing a chemistry module, the difficulty ramps up automatically. Struggling a bit with physics, it dials back, offering real-time feedback and built-in assessments to guide you. It customizes the entire experience so you master scientific reasoning at your own perfect pace.
Let's hit Section 5, the PraxiLabs experience, science in 3D. To see how this is actually working in the real world today, let's look at a platform called PraxiLabs. They're already providing these incredible 3D environments where university students carry out experiments just like they would in a multi-million-dollar physical lab. Instead of just staring at theoretical formulas on a whiteboard, you can actively test physical laws across major academic disciplines.
And the scope of what they cover is just huge. In chemistry, you can do everything from radical detection to electrochemistry. In physics, you're exploring thermodynamics and wave experiments. Biology, you've got molecular biology, toxicology, cell culture, you name it. It is a fully equipped virtual space waiting for you to jump in, experiment safely, and really build your skills.
So, I want to leave you with this final thought. We know these virtual environments boost motivation, cut costs, and keep everyone safe. But let's think bigger. If virtual labs can so drastically redefine how science is learned today, how will they redefine what we actually discover tomorrow? When we remove every physical, financial, and safety barrier to human curiosity, the possibilities for innovation are truly limitless. Thanks for joining me for this explainer, and keep exploring.